All right, welcome to The Explainer. Today, we're diving into one of the most exciting and frankly misunderstood topics in tech right now: AI agents. You've probably heard the term thrown around, but what are they really, and why is everyone saying they're the next giant leap for artificial intelligence? Let's get into it. So, let me start with a question for you. What in the world connects the simple GPS navigation on your phone with a fully self driving car? I mean, they seem like they're from different planets in terms of complexity, right? Well, the answer is that they're both built on the exact same powerful idea: the AI agent. This is the concept that's moving AI from just answering our questions to actively getting things done out in the real world. So, what is an AI agent exactly? Here's the core of it: it's a system that can perceive its environment, see, hear, or just read data. Then it can reason about its goals, basically thinking through what it needs to get done. And here's the most important part: it can autonomously execute actions. That one word, autonomously, is the entire game changer. It's the difference between a simple tool and an actual worker. We can actually boil this whole thing down to a super simple but incredibly powerful three-step loop: sense, think, act. First, the agent senses the world around it. Then it thinks, using its AI brain to figure out the best move. And finally, it acts, using whatever tools it has to make a change in its environment. This little cycle right here, it's the engine that drives every single agent, from the most basic to the wildly complex. Okay, so here's our game plan for today. First, we're going to nail down what an AI agent is. Then we'll look at the actual blueprint for building one. After that, we'll climb what I call a ladder of intelligence to see the different types. We'll check out where they are in the real world today, and then we'll wrap up by looking at what this all means for the future of intelligence itself. All right, first things first, let's clear up some confusion. You hear all these terms: bot, model, assistant, agent, and honestly, they get used interchangeably all the time. But they mean very different things, and understanding that difference is the key to getting why agents are such a big deal. This table really lays it all out. Think of an AI model, like a large language model. It's just a passive engine. It's like a brilliant brain in a jar. It can think, but it can't do anything. A bot is just a script follower, super simple. An AI assistant, like the one on your phone, is a collaborator, but it just waits for you to tell it what to do. An AI agent, though, that's an active system. It senses, it plans, and it goes after its goals all by itself. That high autonomy, that's everything. So how do you actually go about building one of these things? If you wanted to create an autonomous system, where would you even start? Well, it turns out there's a kind of universal blueprint that engineers use for any agent you can imagine, whether it's a self-driving car or a simple customer support agent. It's called the PAES framework. PEAS is just an acronym for four key things you have to define: the performance measure, how do you know if it's doing a good job? The environment, where does it live and operate? The actuators, what tools does it use to take action? And the sensors, how does it see the world? You define these four things and bam, you've got the complete blueprint for any agent. And just look at how flexible this is. For a self-driving car, performance is all about safety and speed on the road. Its actuators are the steering wheel and brakes, and its sensors are cameras and GPS. Now look at a customer support agent. Performance is user satisfaction in a digital chat. Its actuators are the text messages it sends, and its sensors are the messages it receives. Same framework, two totally different worlds. It's pretty amazing. Okay, so we know the blueprint. Now let's talk about what these agents can actually do. Because not all agents are created equal, not by a long shot. The best way to think about it is like a ladder of intelligence. With each step up the ladder, the agent gets a powerful new capability that makes it smarter and way more autonomous. At the very bottom rung, you have this simple reflex agent. This is as basic as it gets. It works on pure if-then logic. Your thermostat is a perfect example. If the room is cold, then turn on the heat. That's it. It just sees something and reacts. It has absolutely no memory of what happened even 1 second ago. And as you can imagine, that no memory thing is a huge problem. It means these simple agents can get trapped in endless loops, just making the same dumb mistakes over and over. So, to climb to the next rung on the ladder, we have to give the agent one crucial thing: a memory. So, what happens when you give an agent a memory? Well, you get a model-based reflex agent. And this is a big deal. It keeps an internal model of how the world works, which lets it deal with stuff it can't directly see at that exact moment. For example, a self-driving car uses its model to remember that another car is still in its blind spot, even if the camera can't see it for a split second. But there's still a ceiling here. Even with a memory, the agent is still fundamentally reactive. It's just responding to what's happening around it. It doesn't have any ambitions of its own. To climb higher, we have to move beyond just reacting and start actually planning. And that's where goals come in. This brings us to goal-based agents, and it's a massive leap forward from reactive to proactive. Your GPS is the perfect example. Its goal is to get you to your destination. It doesn't just react to the next intersection. It proactively plans the entire sequence of turns from the very beginning to achieve its goal. But there's a catch. A simple goal-based agent will find a path to the goal, sure, but not necessarily the best path. To the agent, any route that gets you there is just as good as any other. To do better, the agent needs some way to figure out what best even means. And that's where utility-based agents come in. These are really sophisticated. They use something called a utility function, which is just a way of scoring how good or desirable any particular outcome is. This allows them to juggle complex trade-offs. A self-driving car doesn't just want to arrive, it wants to maximize utility by balancing speed against safety and comfort against fuel efficiency. It's an optimizer. Finally, at the very top of our ladder, we have the learning agent. This is the most powerful type, for one simple reason. It can improve itself. It learns from its experience, gets feedback, and gets better at its job over time, all without a human having to reprogram it. This is the agent that actually learns from its mistakes. So as we've climbed this ladder, you might have noticed a fundamental tension starting to appear. The more intelligence and autonomy we give an agent, the less predictable and understandable it becomes. This trade-off between power and predictability, well, it's not just some small engineering problem. It is the central defining question in the entire AI safety debate. Okay, that was a lot of theory. Let's bring this all back down to earth. Where are these agents actually being used today in the real world? And what are the big challenges people are facing when they try to deploy them? The truth is, they're already everywhere, and they're having a huge impact. You see them in self-driving cars, obviously, but also in the swarms of robots running Amazon warehouses. They're in cybersecurity, hunting for threats way faster than any human ever could. They're optimizing massive global supply chains and powering the next wave of customer service. This is not science fiction. This is transforming industries right now. But all this incredible power comes with a new kind of risk, a concept some people are calling agentic debt, and it works just like financial debt. You get the immediate reward of the agent's productivity, but you're also taking on the long-term cost of governing and managing the risks of this complex, unpredictable system. And if you ignore that debt, a single failure could wipe out all the gains you've made. And all of this brings us to our final big question. Where is this all heading? Because developing AI agents isn't just about making better tools. For many people working in AI, this is the most direct path to the ultimate goal of the entire field: artificial general intelligence, or AGI. But the future might not be about creating one single super smart agent. It might be about creating teams of them. This quote here points to a really profound shift in thinking. Once you start building systems where lots of agents have to work together, your job stops looking like programming and starts looking more like organizational design. You're not a coder anymore. You're basically the CEO of a digital company. And that leaves us with this final, fascinating, and kind of mind-bending question. When we finally get to AGI, will it be a single monolithic superbrain, like something out of a sci-fi movie? Or could it be something totally different? A society of minds, an intelligence that emerges from the complex collaboration of millions of smaller, specialized agents, a lot like how human civilization works? The answer to that question will probably define the future of intelligence, both ours and the one we're building.